The ICI student chapter of MITS has emerged as an excellent initiative in providing a platform for students to qualify as good civil engineers. Here is yet another technical presentation on behalf of the initiative taken to encourage and engage students in other activities during this pandemic situation. Today, we'll take a look at the 3D printing application in construction. 3D printing is not new to many of us, no doubt, but the same cannot be said about the construction industry. Over the years, we have come to realize that the construction industry has pretty much remained the same in day-to-day construction activities. This was until 2004 when Professor Behrouz Khoshnevis of University of Southern California built the first 3D wall. That act brought the 3D printing technology to a remote position and till date there have been numerous applications of the technology. Okay, let's discuss about what is 3D CP or 3D concrete printing. Basically, it is a form of additive manufacturing used to fabricate buildings or construction components in completely new shapes not previously possible with traditional concrete framework. We can name 3D CP as rapid prototyping or additive manufacturing also. It is called additive manufacturing because a new material is continually added to it when it wants. It's a production technique which is controlled by a computer that builds a product layer by layer. I have already mentioned about the history of 3D CP. It was Dr. Behrouz Khoshnevis, a researcher from the University of Southern California, who developed a system called contour crafting in the mid 2000s that paved the way for present day's 3D concrete printing. Now, let's talk about what a 3D printer is. It's a device designed to produce scanned 3D models on a computer by using various materials without the need for an extra mold. It's also known as a production method for desktop manufacturing or additive manufacturing. In this technology, 3D computer design is transformed into a real object. It is considered as an eco-friendly product that offers virtually unlimited possibilities to implement geometrically complex structures when compared to traditional building construction techniques. There are three general principles behind the working of 3D printing. First one is modeling, other is printing, and the last one is finishing. Using CAD software program, we can create the 3D image of an item, and this information is sent to the printer. Then the printer generates the item by depositing the material layer by layer. In order to harden the material, light or lasers can be used. Now, we can go through how does 3D concrete printing works. Simply, concrete 3D printing works in the same way as that of a gigantic fused deposition modeling printer or FDM printer that uses concrete instead of plastic filament. Like FDM printers, concrete 3D printers are also controlled via G-code, which is a machine language that works by directing the print head of the 3D printer until the desired 3D model is produced. The 3D printing approach consists of three general stages. First one is path and data generation. There are a variety of methods implemented for the generation of building paths. A general approach is to slice a 3D shape into flat thin layers with a constant thickness which can be stacked upon to each other. Second stage is material preparation stage. It includes mixing and placing the concrete into the container. Once the fresh concrete has been placed into the container, it can be conveyed through the pump pipe nozzle system to print out self-compacting concrete filaments which can be built layer by layer structural components. The last stage is component printing. To execute the printing process, a control system is required. These systems can be generally split into two categories. First one is Gander system and the other one is robotic arm system. Gander system drives a manipulator mounted onto an overhead to locate the print nozzle in XYZ Cartesian coordinates. And the robotic arm system offer additional degrees of freedom to the nozzle allowing more accurate printing workflows. We are moving on to the benefits offered by 3D concrete printing process. First one is ultimate form follows function efficiency. New design possibilities to leverage optimal structural forms by combining materials and features. New customized complex designs and structures are possible. The main advantage is construction cost is low. Another advantage is it digitalizes and industrializes your process to streamline construction and reduce material waste. It also improves production of higher quality elements by utilizing machine perfect fabrication. Time saving, increased productivity, automated process with less labor, high durability, environment friendly, no pollution, no waste, etc. are some of the relevant advantages of 3DCP. There are some disadvantages too. Reduced employee numbers in the industry, since 3D printer does most of the work. High risk, any errors in the digital model can result in problematic issues on site during the printing or construction phase. Conventional product manufacturing companies and plant renting companies could suffer as their products are no longer required. In this section, we lay down some of the recent and popular applications of concrete 3D printing to give you an idea where the technology is currently used. In early 2015, Shanghai-based Vincent Decoration Design Engineering built 10 3D printed houses under 24 hours. They were able to achieve this feat by spraying a mixture of recycled raw materials and quick drying cement using their massive 3D printers. Development of Kondu crafting process. Building of disaster relief shelters. Some companies made cost-effective off-grid dwelling aboard, which could also be instrumental in solving housing problems after disasters. Another applications are printing of 3D bridge and canal, construction of metal frames for solid structures. These are some of the examples. Let me conclude. Large-scale cement-based 3D printing disposes the need for conventional molding by precisely placing or solidifying specific volumes of material in sequential layers by a computer-controlled positioning process. 3D printing at a construction scale will have a wide variety of applications within the private, commercial, industrial, and public sectors. The technology has seen a significant increase in popularity in recent years with many new companies. This led to several important milestones such as the first 3D printed building, first 3D printed bridge, and many more. These are some of the YouTube video links where you can find the working of 3D concrete printing. Thank you.